files, tutorial 1 and tutorial 2, Chandrasekharan sir. Shortly he will share with you, right, simulation file at least, so that you can play with these files and according to your need. In tutorial 1, I have taken this initial position of reference frame as a input. So here you can control that position, whether it is to be placed at 0, pi by 2, minus pi by 2 pi, whatever it is. So it is taken here only. To see the decoupling, P ref and Q ref you can put here, and you can see this V alpha, V beta. Some changes are done here, I will show you. This is minus pi by 2, so what do you think? Just quick revision. Minus pi by 2 means Vd will be positive, Vq will be 0. So Vd is positive, Vq is 0. This is how it now it is looking like more interactive. You can do it. So this file is shared with you. Second tutorial was this half bridge, and we were trying to get its we tried to get its mathematical model in the class, and we then tried to simulate it, average model and switched model. So average model, only D to be used. The current source will be DIA and voltage source will be DVDC. In switched mode, this D is replaced by actually switching signal S. How to get S? Simply compare D with carrier wave, and this you will get the switching signal. The problem we were facing yesterday was algebraic loop problem. The problem is because of this is output current IA, and the same current is to be used as a source also. So MATLAB get confused. Which one do we consider first? Because it's at output also, it is as a input also. So the usual way is use delay, unit delay. I was trying to use delay Z minus 1, and that time it was not working. Now I have used 1 upon Z, it is working. Because for the same function, MATLAB is having multiple blocks. So I think this block is compatible with this. So now I have made it easy for you because it is to be given. So from here you can select the mode, which ones to be used. I mean switched model and average model. So currently I am using D, putting at D. So it is written switched model put both poles at S, average model put both poles at D. So I have put at D. Now I can run this. Okay.
Because you said no, it is shared with them. So I think you don't have these files, right? Ask the email and then first you can share.
No, this is to be done by them only. Okay. They were having some issues, so I did it.
They have
now they will be having. They have to make by their own. So this is the average mode. If I'm so here is the command. I have changed the command from 0 to 1000 and then 1000 to minus 1000. So it is. And now if I will choose switched model, then I will click on switched model and I will run it. this is switched mode. Correct? Ripple is approximately 10% of the rated current. It depends on the inductor how you choose. You can choose for 2%, 1%, but industry applications are okay with 10%, 15% ripple in the current. Because if current ripples are going down, you will need higher value of inductance. Higher value inductance, big size of inductor, cost will increase. So there is compromise between size of inductor and हाँ अपने लैपटॉप निकालना लेकिन मैं बताऊंगा अभी कब निकालना अभी आप मैं जो एक्सरसाइज करने वाला हूँ वो हम थ्योरी थोड़ा देखेंगे उसके बाद फिर आप स्टार्ट करेंगे सो फार वी हैव डन हाफ ब्रिज सेल इज देयर एनी इशू हाफ ब्रिज इज ओके ओके Okay. Okay, please. Yesterday we have seen that half bridge cell, the pole voltage swing between VDC and 0. The average value of the pole voltage is given can be dVDC. If you want to make AC out of this, then you have to modulate D because D can have value between 0 to 1. You have to choose D very carefully. It is 1 by 2 plus 1 by 2 sin omega t. Even you want to change the amplitude of sine wave, then you have to insert one more factor here m. So if m is 0, there is no sine. If m is 1, you are having full potential. Correct? This m is known as modulation index. Okay. So here the average value of pole voltage will be having two components, AC plus DC. How much AC you can get? M VDC by 2, where M is the modulation index. So maximum, if DC is fixed, what is the maximum value of the AC you can get? M times VDC by 2. This is the peak value, and average value, RMS value is by root 2. Generally, you never operate your converter at modulation index 1 because you will not get clear switching pulses when it will be approaching very near to 1. So you restrict your converter at 0.9, 0.95, not very close to 1. So for that you need to, if M is, you have limited M is equal to 0.9 and you want VAC to be 220 RMS, then you have to calculate your DC link what it should be. So VDC will be 2 times 220 into root 2 upon M into 0.9. So at modulation index 1 you will have a requirement of minimum VDC. If you are going down to limit your modulation index 0.9, 0.8, you have to, it is having some cost, the cost in the sense of DC link voltage. You will need higher DC link voltage. The same concept can be extended to 3-phase signals also, 3-phase system also, to make a 3-phase inverter. Their structure would be something like this. if you extend this mathematical model to three-phase system, the inverter will be looking like some, you can, if it is grid connected, then you can connect to grid. This is the model. What will be dA? dA will be 1 by 2 plus 1 by 2 m sin omega t. dV would be 1 by 2 plus 1 by 2 m sin omega t minus 120 and plus 120 or minus 240. As I discussed in the very first tutorial, when it comes to control, you always do transformation, because DC currents are easy to handle by a simple PI controller. Otherwise, if you are dealing with AC quantities, you will have to go for higher order filter or compensator. If you see the mathematical equation here, suppose inverter voltage is, I am taking VIA, VIB, VIC. Oh, where VIA is DA VDC, VIB DV VDC, DIC DC VDC, and output current is IA, IB, IC. It is passing through RL, and then grid voltage is VGA, VGB and VGC. What is the KVL equation for this? VIA is equal to RIA plus L DIA by dt plus VGA. Can you write three equations for each phase? Okay. multiply equation number 1 by EJ0, multiply equation number 2 with EJ 2 pi by 3, multiply equation number 3 with EJ 4 pi by 3, add them and multiply by 2 by 3. So it would be 2 by 3 times VIA EJ0 plus VIB EJ 2 pi by 3 one more time plus VIC equal minus J2 by 3 or J4 pi by 3 equals to R into 2 by 3 same IA EJ0 plus IB EJ 2 pi by 3 plus IC EJ 4 pi by 3. I know most of master students or PhD students over here, they will be knowing I am deriving this expression for BTech students because they are very new to this. Plus L d by dt of 2 by 3 times IA EJ0 plus IB EJ 2 pi by 3 plus IC EJ 4 pi by 3 plus 2 by 3 times of VGA EJ0 plus what do you think? You have seen this term? This type of term? Somewhere? What is this? Something in the very first session, space vector. This is the definition of space vector. XA, 3 signals XA, XB, XC. Then the space vector is defined as 2 by 3 times of XA e power j0. Yes. So this is nothing but space vector of inverter voltage, space vector of the current output, space vector of the grid voltage. Okay. So this equation can be written as VI vector is equal to R I vector plus L di vector by dt plus Vg vector. Okay. You know that this V vector, any vector, whether it is Vi, Vg or I vector, it can be written as stationary frame also, because alpha was real part of vector and imaginary beta was imaginary part. Okay. मैं हर बार गलती करता हूँ, sorry. This vector can be written in stationary frame also, V alpha plus J V beta. It can also be written in DQ frame. Okay, suppose you are writing this. Replace all the vectors by alpha and beta component. So this Vi becomes Vi alpha plus J Vi beta, V G becomes Vg alpha plus J Vg beta. I becomes I alpha plus J I beta. If you replace this, segregate real part, imaginary part, you will have two equations. So this is discussed in the class that transformation, Clark transformation or stationary frame transformation converts three equations into two equations. Okay. So it becomes V alpha, Vi alpha is equal to Ri alpha plus L di alpha by dt plus Vg alpha, and Vi beta is equal to Ri beta plus L di beta by dt plus Vg beta. This is the representation of the three equations which were in ABC frame, and this is the same system in alpha beta frame. So equations are has come to 2 from 3, but the nature of waveform is going to be same, sinusoidal only. So controller, number of controller will be reduced to 2, but you have that issue. You have to use higher order compensator to get the desired result. Now what to do? This equation, there is one more concept we have gone through. Whatever we are covering, I am writing, it is covered in the previous class. You just need to remind. This vector V V dq was V vector into retardation factor minus j theta. Theta is the speed of angle of the reference frame, and I will make sure अब नहीं बोलना पड़े. So VDQ is equal to V vector and retardation factor, क्योंकि आप दूसरे रेफरेंस फ्रेम से देख रहे हो जो थीटा ओमेगा आर से या थीटा आर यहाँ पे लिख दो, इससे घूम रहा है. Where theta r is equal to omega t plus theta r naught. If you remember, we have discussed in the class. So what do you think? And what is this d theta r by dt? Speed of the at which it is rotating, right? Speed of rotation. Can you take this term this side? Then V vector becomes V dq E j theta r. And remember, V dq is, I told you V dq is Vd plus j vq. You replace this term for each vector. Suppose Vi vector is there, then Vi dq E j theta. Suppose I, then I dq j theta. And similarly for Vg, then Vg dq e power j theta. Please replace in the main equation of space vector here. So this Vi vector becomes Vi dq e j theta r. I am assuming it is synchronous reference frame, so theta r will be theta omega t is equals to r I dq e j theta plus L dy dt of I dq j theta plus Vg dq j theta. If you solve this term, second term, you have that differentiation of product A then differentiation plus B then differentiation. So this VI dq e j theta becomes RI dq e power j theta plus L. फिर से नीचे चला गया. मैंने जूम किया है नहीं, फिर से ओके. अपनी कॉपी भी कर रहे हो ना आप लोग. वी आई डी क्यू थैंक यू यार. वी आई डी क्यू जे थीटा इज इक्वल टू आर आई डी क्यू जे थीटा प्लस L I dq same and this j d theta by dt and e j theta plus e j theta d I dq by dt. Making sense? Plus V G D Q E J theta. Now you can cancel this theta term. It is everywhere. This. What it becomes? V I dq is equal to R I dq plus L di dq by dt plus j d theta by dt. It is synchronous reference frame, then theta is equal to theta and theta is equal to omega t. So d theta by dt is simply omega. So it becomes j omega L I dq plus V G dq. Correct? Segregate real part and imaginary part. So this VID is equals to RID plus LDID by dt plus minus, because J will be interacting with JIQ. So it minus omega L IQ plus VGD. Similarly, VIQ is equal to RIQ plus L DIQ by dt plus omega L ID plus VGQ. I think these are the equations which Professor Karimi told to derive yesterday lecture, that I am showing you direct equations. You should take it as a homework. So I have done your homework actually. Okay. Is there any doubt in this mathematics? If you have any doubt, please ask me. Okay. One more aspect. You know that VIA was VDC 1 plus 1 by 2 plus 1 by 2 m sin omega t. इसमें भी जा रहा है? नहीं, इसमें भी जा ही रहा है, तो इश्यू नहीं है. VIA was VDC 1 plus, I can take 1 by 2 outside this bracket, So ma sin omega t. Similarly, VIB VDC by 2 1 plus MB sin omega t minus 2 pi by 3, and VIC is equal to VDC by 2 1 plus MC sin omega t minus 4 pi by 3. MA, MB, MC are going to be equal only. So I unnecessarily I have written this. So M. Can you find this space vector of this vector? And this voltage is 2 by 3 times VIA. The first term VDC by 2, it is having two terms, VDC by 2, then VDC by VDC by 2 times something. If you see VDC by 2, then VDC by 2 EJ0 plus from the second term VDC by 2 EJ 2 pi by 3 plus from the third term VDC by 2 EJ 4 pi by 3, this is going to be 0. So when you will calculate space vector, the DC term will vanish, okay, and this vector becomes M E J theta. Yeah. Okay, in previous equations we have used plus 2 pi by 3.
VIB multiplied by e power j 2 pi by 3. Go back. VIB multiplied by e power j 2 pi by 3. Now you are going for minus 2 pi by 3.
Oh, it's यहाँ पे plus 2 pi by 3. It is correct only. Actually in space, what is the thing? In time domain, okay, minus पीछे. In space, you are here and you are going there, this side. So this axis, if this is the reference, this axis is lagging, minus 2 pi by 3. This is minus 4 pi by 3. So we represent in this way.
Somewhere you can write.
Yes, I will write definitely, sir. So this VI dq becomes M dq actually. यहाँ पे VDC by 2 भी आएगा. Simple. You need to convert the above equations into space vector equations. So this M phasor will be M dq and VDC by 2. VDC by 2 will carry on. So you can replace this VI dq with M dq VDC by 2. So here VID will be MD VDC by 2 and VIQ will be MQ VDC by 2. एक मिनट. Why I am putting my efforts in these equations? Because in the next simulation I am going to make use of these equations. The control block I will show you, it is full of these equations. So you should know that how it is happening, why it is happening. Okay. Again, put this value. So it's touch किया. MD VDC by 2 is equal to RID plus L DID by dt minus omega L IQ plus VGD. mq VDC by 2 is RIQ plus L DIQ by dt plus omega LI D plus VGQ. These equations are not independent. If you see in D component, Q component is coming. This is mentioned by sir that time, and in Q ID is there. So this coupling is there, cross coupling is happening. So to design independent controller for D and independent controller for Q, you have to remove this coupling term, and these coupling terms are added as a feed forward. How it is done? They assume that compensator is going to give UD, and UD is going to be RID plus LDID by dt. Here it is not depending on IQ. Similarly, UQ will be RIQ plus LDIQ by dt. If you want to make closed loop system of this transfer function, it will be like ID ref minus ID PI, it will give you UD, and then 1 upon SL plus R, this will give you I. The same transfer function for Q. So if this term is considered as UD and this component is considered as UQ, so if you know UD and UQ, you can get MVDC by 2 just by adding these both terms as a feed forward. How it will be added? UD, this is UD, VGD, omega L, and here will be IQ. You get this. What? MD VDC by 2. And if you divide it by VDC by 2, you can get modulus index MD. Similarly for Q, UQ, VGD, ID omega L, this will be MQ VDC by 2 divided by VDC by 2, you can get MQ. Once you got MD MQ, you can get inverse spark transformation, you can have DQ to ABC transformation, you can have MA, MB, MC, and this is what they did. Then it will be compared with triangular wave and you can have switching pulses. Now the complete control is, this side will be a compensator which will be acting on ID ref, here ID, this ID will be going on this side, IQ ref minus IQ, and this IQ will be going this way, and here compensate. Today actually my this tutorial and professor lecture is going very synchronized way. Today he discussed about PQ control, power control through current. So this is actually current controller. Using PI controller, it's not LQR. So it's partially feedback. Now from where this ID ref and IQ ref will be coming? So this is okay, current controller, because we are going to make use of this. You know that we have learned that if you are aligning a reference frame in a particular direction, you can make VD0 or IQ and VD0, VD or VQ. One of them will be 0, correct? If the vector is aligned, if signals are sinusoidal, sin omega t minus 2 pi by 3 something, then the position of the space vector at t is equal to 0, it's 90 degree behind the A phase axis. Don't see like this. I have covered, right? If signals are cosine, cos A, cos B, cos omega t minus 2 pi by 3 something, then at t is equal to 0 you will find that space vector position is aligning the A phase. Okay. In our simulation, the simulation which I am going to show, I have taken cos as a function, cos omega t something. Then for those signals, space vector position at t is equal to 0 will be along A phase axis. So if theta is equal to 0 also, theta not is equal to 0 also, then VD is going to be maximum and VQ is going to be 0. Okay. So in our case, generally it is done from PLL, but in this simulation I have not used PLL, I have directly taken information on theta from the signal. Okay. So in our case, VD is going to be Vmax and VQ is going to be 0, because space vector position is here and VD is this side and VQ is this side. So VD is the peak value of this voltage and VQ is 0. Now what is the expression for active and reactive power? P is equal to 3 by 2 VQ is 0, VQ is 0, so it becomes VDID. What is the expression of Q? VQ is 0, then sir has discussed one term, that power control via current. So if inverter is there, it is connected to the grid and you are instructing inverter to feed some amount of active power into the grid. Suppose 10 kilowatt power to be injected in the grid, or some 5 kVAR reactive power to be supported to the grid. So this command will be coming from the user or power plant operator, that this much power inject into the grid. So if P ref and Q ref is given, VD is not in your hand, it is directed by grid, then you can't calculate this ID and IQ ref. So ID ref is nothing but 2 by 3 times P ref upon VD, and IQ ref is 2 by 3 minus 2 by 3 times Q ref upon VD. Making sense? So I can add some portion here, that P ref will be coming, and Q ref will be coming. It will be divided by VD, and then making sense? क्या हुआ योगेश? Please ask. No. Whatever you are measuring, you will confirm that whether you are injecting the same power which you have commanded, whether the same power is being injected in the grid or not. P ref and Q ref is the commanded value. I am giving direction to the inverter to feed this much power into the grid. If command is given,
and I have power in ABC.
huh, both will be same. Yeah, both will be same. If you are calculating active power, instantaneous active power VAIA plus VBIB plus VCIC, and this P ref will be same. Yes. Okay. Once MDMQ is fine, this modulation index, you will convert MDMQ into DQ to ABC using the same theta which is used to convert ABC to DQ, and you will have this MA, MB, MC. Okay. And from MA, MB, MC, you can have this duty ratio, because this will be moving between +1 to -1, and you want duty ratio to be confined to 0 to 1. So you can add here +1 and you can divide by 1 by 2, then it will be dA. Similarly dB, dC. This is average model. If you want to use Swiss model, you can compare this dA by a triangular wave which is moving from 0 to 1, 0 to 1, and even you can use triangular wave here also, MA, MB, MC between -1 to +1, and you can have those switching signals. If this is the This Pi is only handling this transfer function SL plus R. Then Kp will be L upon tau, Ki will be R upon tau. If this is the transfer function, it will work fine. Since you are dealing with this average model, you can take this tau 1 millisecond something. Otherwise, sir told in another way today, but the objective was same. He has taken this transfer function. He was saying that it should be less than 5 times, 4 to 5 times, something like that. Okay, time constant should not be so fast, so that it can cross switching frequency also. It should be limited by at least 2-3 times lower than the switching time. Okay. Otherwise operation will be unbalanced, uncontrolled. So in our simulation, this is going to be system. This is going to be system. We are sensing. What we need to sense? IABC, VGABC, VDC. Three things we will sense. We will convert into DQ and this is not required. For conversion, you will use theta information from phase A. So from ABC to DQ conversion, two options are there. You can use directly block there, but you have to be very sure that what it is doing, which component is going to be positive, but which component is going to be 0. But yeah, fortunately there are only two options given. It's 90 degree behind or align. So you can use align one for this simulation. For cosine, if signals are cosine, then you can use align one. If it is sine, then you can use 90 degree behind, so that VD component will be positive and Q component will be 0. Wow. So this is all for today's simulation. Now I am switching over to, I want to show you first that this is how it is done, then you will do. Okay, this will be right practice. So far any problem, any issue, any doubt? कोई डाउट नहीं, समझ में आ रहा है? देखो ट्राई करोगे तो ये आएगा, ये इतना कठिन नहीं है. Apple. कितना भरा हुआ है? 1 minute. It's opening. Yes. I will share this simulation with you all. I mean, your professor will share. हाँ मेरे पास पहले से सिमुलेशन पड़ा था सर. I will change. I mean, they will do by their own. Since professor is from USA, that's why we are following their standards. Okay, see. Inverter model is simply system model we have used, this mathematical model which we have derived. L as a filter, then grid is there. I told you we need to measure grid voltage and current, so measurement block is there. VDC is there. Here you need to convert ABC to DQ. So current IABC is being converted into IDIQ. This grid voltage converted into VDVQ. Here I am calculating active and reactive power. Initially I was using some other block, but yesterday only I changed according to the way I taught you. So this is the code I inserted, and same code which will be given to you to convert DQ, ABC to DQ. This theta I am directly taken omega into T, which is used to in the same phase, same grid voltage. Okay. Control circuit, this Pref and Qref is given. Pref and Qref will be given by user, and then section by section we can see. Pref came, you have divided by multiplied by 2 by 3 and divided by VGD, you get ID ref. Making sense according to theory? You got Q reference, multiply minus 2 by 3, 2 by 3, divided by VGD, you got Q ref. Okay? Please let me know if we are deviating from the theory. ID ref, ID is passed through compensator, you will get this point UD. Similarly here, UQ, ID ref, IQ ref and IQ pass through compensator here. Then UQ came, then plus cross coupling omega L IQ plus VGD, you get MVDC by 2 here, you have divided by VDC by 2, you get MD here. Same theory. Here UQ came, अच्छा यू क्यू समझाया था मैंने आपको, डी नहीं समझाया. Same for D or Q, whatever it is. Then you got MD, MQ. You have converted DQ to ABC. Then you have multiplied by here MABC will be switching between -1 to +1. You want to have these signals between as a duty ratio, so between 0 to 1. So you have pre-multiplied by 1 by 2. So it becomes, it will confine to -0.5 to +0.5. Then you have added half. So it's similar like you add 1 then multiply by 1 by 2, or multiply by 1 by 2 first and then add half. You will get DA, DB, DC. Okay. Now, for phase A, current control, what is the current control source? Current controlled, no, voltage controlled, no, current controlled current source. Huh? Current controlled current source, right? What is the value? DIA, DAIA. So here DA, IA is coming, DIA. What is the voltage value? DA VDC. So DA VDC. This VIA and IIA should be given to phase A. VIA, IIA. Similarly, for this is generated, this is generated. I have given a random command for Pref, Qref. It should be 50 kilowatt initially up to 0.1. Then it will reduce to minus 50 kilowatt, then it will again go to 50 kilowatt, then it will stay there. So we need to see that whether it is changing or not. Similarly, Qref, it is kept constant 0 till 0.5, then it is changed to 20 kVAr. It is maintained to that value till 0.7 and then it is reduced to negative 20 kVAr and stayed at back that value. So these are the commands given by user, that you modulate this, regulate P according to this graph and Q accordingly. So using this P, Q, you will get it ID ref, IQ ref, and then current controller comes in the picture and will try to generate the modulating wave according to that. So let's run this. Yeah, please. Anti wind up actually required when your this output go through saturation block. So then anti wind up is needed. If it is not going in saturation, anti wind up is not needed. I have not used saturation. It is generally there, but if you know that current is not going to cross the limit of your device, then Generally people when they are doing a hit and trial mode for this tuning, then current goes very high, then they put saturation. But it's not like that. In real hardware applications also you put limiter, so that it will, sir told that it will respect the rating of device, because power witness devices are having limited by the current rating. So that's why. But it is recommended to use anti-binder. Yeah, it is recommended. Okay, simulation is running is complete. You see, according to command, current is changing its direction. For initial phase it was positive, then it's negative, then again positive, it is changing. If you will see along with voltage, so here in this portion current and voltage in same phase, then here current and voltage in opposite phase, because negative power is there. Yes, opposite. Yes, correct. Acting as a rectifier, and then again positive. I have given power references like this. Yes. Yes. Yeah. Yeah. Everything is same. Everything is same. You are more than happy, right? Okay. Yeah. What is needed then? You will not be having battery. You will having load. You will be having DC link capacitor. That time you will have to add one more loop to maintain that DC link voltage. I have that simulation for the subsequent day. I will come to that. I have touched current controller today. I will touch voltage controller and current controller combined in subsequent. We have surprises for you. Yes, we will. Here you can see this VGD is positive peak and VGQ is 0. Actually, this design was done by me taking a reference from a paper. So that's why these values are according to US grid, 60 hertz and 120 volt, I think, phase to phase voltage, 120 phase to phase voltage. I will give you this simulation. You can modify according to your requirement. Okay. This is modulation index. You can see that, yeah, for 0.1 it is constant, then it is slanted, it is decreasing, then again constant, then it is increasing, then constant, then the slope is there. Whenever there is change in the power reference, it is reflected on modulation index. Yes.
Sometimes modulation index is exceeding 1.
Where?
What is the sometimes?
For you.
What is the reason for that?
There are the very first reason is your controller is not very tuned perfectly. Your model, the control model you have made, you have done some mistake. tuning nahi, the mathematical modeling itself, the control structure which you have made, this is not proper. The first thing. Second thing, your parameters, compensatory parameters are not so cool. And the very third one, if they both are correct, then you have loaded your inverter beyond the capacity, or you have chosen DC link to be very small compared to the grid voltage.
We have divided one factor as VDC by 2.
Yes.
Ideally, VDC by 2 factor we have to divide.
Yeah, we divide actually.
We have to divide VDC by 2.
Yes. So DC link to be chosen appropriate enough so that you know that in the rated condition your converter is going to operate at 0.8 or 0.85. If you have taken DC link too small, you have not given any margin. You said that at rated condition 10 kilowatt, the converter is designed for 10 kilowatt power. So when it will be operating at 10 kilowatt, it will be having modulation index 1. But and the fourth condition to go in the overmodulation is reactive power. You have designed your DC link according to active power sharing. When reactive powers comes in the picture, it requires more DC link. So if you are feeding reactive power, then you need more DC link. One real life example of that is, generally inverters installed at solar power plant, they are asked to feed some reactive power in the night time because converters are free, there is no solar. So if you see the structure of STATCOM, grid connected inverter, active power filter, same only, inverter, filter, grid. So solar inverters are asked to feed some 30%, 20% reactive power to the grid in the night time to support that grid. So at one site, when the command was given that okay, insert 30% reactive power, inverter was tripping off, it was not working. Then this issue remains for 15 days, 16 days. Finally, what was the problem? They have designed the DC link according to the active power. Then when inverter will be fully loaded like 10 megawatt, it will be operating at 0.95 modulation index. According to that, they have selected DC link voltage. But when they asked the system to inject 30% of reactive power, then in DC more DC link is required. So DC link has increased. So it has reached the threshold limit and circuit breaker off. That's why this switching was happening. So I came to know, just got to know that I should tell you that DC link, more DC link is required if you are operating the same structure as a STATCOM or as a inverter simply. Okay. T break. Now you will do in your system this same KPKI, same, you need to make a structure and then do it. Until unless you will not do it, you will not get it. For BTech students, you should do it. They are very intelligent, but I am also PhD, what should I tell them?
How to calculate the theta value?
In simulation I have taken